In this video, we'll be exploring the lattice algorithm for addition, both how to do this algorithm and why it makes sense. We'll start with two 3-digit numbers, 687 and 594. We'll be modeling these with base 10 manipulatives, and I'll use the standard shorthand that you can see over here in the key. Let's start with our first number. We have 687. So we'll have 6 flats, 8 rods, and 7 of the ones. Next, we'll model 594. In our written work, we make sure to align by place value. This is the same as with the traditional algorithm because we want to be combining like-valued parts. This is really clear in the manipulative work, where we again line our like-valued parts so we're combining the same manipulatives. We'll have 5 flats, 9 rods, and 4 units. Once we have our numbers aligned by place value, we draw the lattice underneath. This is just a rectangle with vertical lines separating the different places, and then a diagonal line drawn through. When I add 7 plus 4, I get 11, and I record it in the grid below. With the traditional algorithm, we split the 11 and carry the 1, and so then the number is split into 2 separate parts, one above and one below. With the lattice algorithm, we keep the number together, which can be helpful for some students. In our manipulatives, we see that we can combine 10 units into 1 rod with 1 unit left over. In the tens place, 9 plus 8 is 17. With the manipulatives, we combine 10 rods to make a flat, and then we can see that we have 7 rods left over. And in the hundreds place, when we add 6 and 5, we get 11, and we can combine 10 of the manipulatives together to form a cube, which is 1,000. And we have 1 flat left over. When we've built it with manipulatives, we can see that our like-valued parts align diagonally. Here we have the ones, the tens, the hundreds, and the thousands. So when we add, we're going to add along the diagonal. We end up with 1. 7 plus 1 gives us 8. 1 plus 1 gives us 2. And we end up with 1,281, which corresponds with our picture here. We have 1,000, 200s, 8 tens, and 1 1. The advantage of this algorithm is that you don't split up the sum of each column. In summary, with the lattice algorithm, we align by place value in order to group like-sized parts. We record the sum of each column in the lattice structure. As we saw with our manipulatives, we have like place values aligning diagonally with the ones, the tens, the hundreds, and the thousands. We could, of course, go further than this, so we add diagonally in order to add like-valued parts. This algorithm doesn't completely get rid of the need to carry. However, it does tend to reduce it. Let's do another example. We will add 1 plus 6 to get 7. I'm going to record a 0 because I didn't have anything in the tens place. 9 plus 1 is 10. 4 plus 5 is 9. When I go to add diagonally, I get 7, 0. Here, I'm going to have to carry. 9 plus 1 is 10, 0, carry the 1, and I'll end up with 1007. One reason to teach the lattice algorithm is because many students like the multiplication version of the lattice algorithm, and this gets them used to adding diagonally, which is needed in the multiplication algorithm.